All right, this is part 2. Hopefully I'll get through questions 10 through 20. I was only able to get through 9 in the first video. All right, so let's pick it up. Living with parents. A Pew Research analysis stated that in 2012, 36% of the nation's young adults ages 18 to 31 in the so-called millennial generation were living in their parents' home. After reading the analysis, statistics students wanted to design a study to determine if the percentage was higher for the millennial students who attended his college. Before collecting data, he set the significance level for his test to be 0.5, for which p-value below would he reject the null hypothesis. So, the p-value represents the probability of obtaining a sample as rare or as extreme, a sample proportion as extreme as the one that would be indicated from a population that should have been 36%. In other words, this person is setting the threshold to be 5%. So if the sample proportion that was conducted actually would occur less than 5% due to random chance variation, that would be enough evidence to suggest that the number is actually different for this student's college. So in this case, what I'm looking for is the p-value to be less than the significance, and we use the alpha for the significance. So I want this number over here to be smaller than 0.05. Okay, and the only number in the question that does so is this one. 0.02 is less than the 0.05. So 2% of the time is rare enough that I would consider that this student's college has a different proportion of millennials staying home than the national proportion. All right. For this question and the next one, this is referencing type 1 and type 2 error. A much more thorough explanation is offered here in this video about notes about type 1 and type 2 errors and their explanation. Essentially, they mimic the errors that we were finding when we were doing Unit 6 with false positives and false negatives. And so that's what we're kind of looking at in this case. So let's just set this up real quick and see if we can kind of get our head wrapped around this. So essentially what they're saying is the food is safe. That's what we want to believe when we go out and eat at a restaurant. And the food is not safe would be an alternative hypothesis that perhaps even food poisoning might bring on, but we're hoping this doesn't happen. But in this case, the food inspectors are inspecting. So here's what happened. The sample suggests that the food is not safe. So they're saying this is true. But the food is actually safe. So what did I do in this case? I rejected the null, even though the null equaled true. So I made a mistake. And this type of mistake, when you reject the null, is called type 1 error. All right, so we'll take a look at the next one. All right, for this type error, a college student hasn't been feeling well and visits her campus health center. Based on her symptoms, the doctor suspects that she is pregnant and orders a pregnancy test. The results of this test could be considered a hypothesis test with the following. The presumption is the student is not pregnant, but the alternative, based on a pregnancy test, would say the student is pregnant. So which of the following is a type 2? So if you recall from that other video, a type 2 error is when you fail to reject the null, which is a fancy way of saying you didn't reject the null when in fact it was false. So the null is false. So what is false for if the student is not pregnant? She is pregnant. So this is false in a type 2 error, and this is true in a type 2 error. But you failed to reject the null. So all the answers here, it says the student is pregnant, but the test came back negative, came back as not pregnant. That's a type 2 error. Of course, the student would have some issues having an incorrect pregnancy test. So that's essentially what this is saying. A type 2 is you fail to reject the null when in fact it's false. The previous question was type 1, you reject the null when it was true. So you did the opposite of what you should have done. For this question, they're asking which of the following situation involves testing a claim about a single population proportion? So I'm looking for something with a percent or talking about something with a percent. So here we go. According to a college board which administers the SAT exam, the average score, oh boy, average is mean. This is not what I want. Okay, in a recent study estimated that 20% of college students in the U.S. smoke. The head of Health Services at Goodhart University suspects that proportion of smokers may be lower there. So they're going to test their students as a one proportion. This is sounding good. Let's make sure the other ones aren't. A certain prescription allergy medicine is supposed to contain an average 245. Oh, here we go again. The word average. So that's mean. So this is not a proportion. And statistics students at a Tacoma college wants to determine whether there's a difference in the proportions, we see the words proportions, of class meetings that male and female students attend. Okay, so I suppose there's a difference in proportions. So this is two proportions, not just one. So in other words, you're comparing one proportion to another. Okay, I kind of have a smudge there. Let me fix that. All right, so that's how you do this question. So the answer is right there. For this question, to speed things along just a little bit, again, we're asking a single population proportion. Okay, so the first one has my single proportion if you want to read through it. It's just comparing the proportion of mental health that adults had at least one major depressive episode in the past year. So it's comparing how many the University Health Center director has received. Okay, so for the other ones, though, you can look pretty easily and see the word average, which is mean. That would be not good. Here's another one with average. This is two mean because there's comparing men and women. This is a single mean. And then finally, there is another question with the word proportion, or an answer with the word proportion in it, but it's comparing. So when you see the word compare, we're comparing the two. That's two proportions. So the answer would be this first one. I'm trying to get a single population proportion. For this question, I look right down here and it says, what is the test statistic? So I'm looking for something like ZTS, the Z-score test statistic, and that's actually located on my template. So I'm going to use that on either my confidence interval or hypothesis test one. Since this has an H0 and an HA, that tells me to use the hypothesis test. Okay, so we'll do that in just a second. So a popular chain of cafes is receiving online complaints about one store location. Regular customers complain that the staff at the location consistently underfills their cups of coffee. The owner of the chain will personally visit the location to meet with the staff if more than 10% of the 16-ounce cups are underfilled by 1 fluid ounce. So it's a proportion of underfilled cups. So she arranges to have mystery shoppers visit the store. The mystery shoppers are people who are paid to pose as regular customers and provide feedback to the owner about the customer service. After 100, that's my sample size, that's my N, visits the store, she finds 18. So 18 would be my quote-unquote successes. Actually, it's not a good thing. Let me get rid of that because that looks like X bar. Hang on one second. This would be my X, because that's how many people actually had cups that were below that was at least 1 ounce under the 16-ounce cup. Okay, so let's open up the template and type in these numbers. So we had 18 successes, pardon me, out of 100 mystery shoppers. And then the null hypothesis, so let's go back and double check what our null hypothesis would be. Our null hypothesis is the proportion is 10%. So let's go back to our template here and put in 10%, or 0.10. And the direction, let's see what they wanted. They wanted greater than. So they wanted to see if the number of cups that were underfilled was greater than 10%. So I would pick right tail. Okay, I didn't have to put in a significance level here because I'm not actually calculating a p-value, comparing it to the critical value. So what I need, though, is this number right here. It's the test statistic. So I get 2.67. So this one then turns out to be a relatively easy question. You end up with that as your test statistic. For this question, we are trying to conduct a hypothesis test. And when we conduct a hypothesis test, we got to make sure that our proportion, or that our sample, has enough successes and failures. And that's based on the presumption of our initial population of 95%. So a school district claims that the normal attendance rate for their school is 95%. So 95% of the students show up every day. So she chooses a school day in October and chooses 120 students. All right, so here's how you check your normality. N times P. Okay, so this is P, because that's my population proportion. And this is my N right here. So if I multiply those two together, 95% times 120, this will be much larger than 10 that I need. But if I do the failure, so this would be the successes of people who showed up, but what about those that were absent? So if I did it this way, 1 minus P, this is my other alternative, I would have 120 people times 5%. Well, 5% times 120 is not, it's less than 10. So that's why we wouldn't conduct this study. So in this case, it is tricky. You want to use this number, but we can't. That's actually what showed up on that day in terms of absenteeism. The number we have to use is this one. And this is why you can't run the test, because this number is less than 10. All right, and this is interpreting what the p-value is. A 2014 study by a reputable Gallup organization estimates 44% of U.S. adults are underemployed. So they did a survey. We select a random of 100 U.S. adults and find that 40% of them are underemployed. So it's a little bit less than what the Gallup had said. So carrying this out, we find a p-value of 21. So what does that mean? Well, the definition of the p-value based on this is to say there is a 21% chance that a sample of 100 U.S. adults will have 40% or fewer underemployed individuals if 44% of the population is underemployed this year, so if it comes from that population. And that's just the definition of a p-value. For this question, it's almost identical to the previous one. It's interpreting what this p-value actually represents. The p-value is 13.3% or 0.133, and it's based on a sample of 200. So you could read through the context of the problem, and then we go down to the answers, and there is a 13.3% chance that a sample of 200 U.S. students in grades, so you have to have the sample listed because you have to identify how big the sample was in terms of how unusual that would be in terms of happening, and then compare it to the population that you're trying to compare it to. So again, this is just the definition of a p-value. For this example, discrimination in the workplace, a large multinational corporation is accused of discriminatory hiring practices tending to hire male employees who are 25 to 30 years old. After management agreed to offer a series of human resource trainings at their various locations, in-house staff examine and analyze their most current hiring data. They look at a sample of 2,000, wow, this is a huge company, new employees and find that the higher proportion of female employees have been recently hired, and the difference is statistically significant. So what does that tell us? Well, if it's statistically significant, so how should we interpret this? Well, there's always this case that, okay, with a large statistically significant results suggest a large improvement. Not always true. Not true. It doesn't basically say that it was a huge difference in who they hired. Regardless of sample size, statistical significance means that there is a meaningful difference. That's not true either. Even the bigger the sample size, the chance is that you could have a very small difference, but it could be statistically significant because of its sample size. So it could be statistically significant, but not practically significant. And that's what this last little bullet is telling us. With a large sample, statistically significant results may actually indicate a small improvement of the perceived discriminatory hiring practices. And finally, our last question is just like the previous one. We have a huge sample, so with large samples, statistically significant results may actually be only a small improvement over the control group. And that's what could happen in this case. So even though you could see something that's statistically significant, it may not be practically significant. I hope this video helped with explaining some of the concepts in Unit 9 quiz.